table. What does this tell me? Nothing. What does this tell me? Nothing. What does this tell me? Nothing. Everything is summarized in one place, and I can go line by line, step by step, from left to right, and then I am able to graph it with no problems. Have any doubts? Very easy to verify, so I'm on page 8. Very easy to verify with the graphing calculator. Please be very careful how you enter it. So in y equals, clear everything you have, and we put in x squared, and we divide by, in parentheses, x minus 1. If you do not add on your own by hand the slant asymptote, which was, I think I'm wrong here. I know I'm wrong. It was x minus 1. So if we don't put the slant asymptote additionally as a secondary or a second function, we're not going to see the graph. Now, can I use the standard viewing window? Yes, I can. The minimum is 4,2. It's okay. So I can go to zoom, and I will choose standard, which is 6. For this function, it will work. Here it is. Of course, the vertical asymptote is missing, but we know it's there. So the function asymptotically starts by, or going, it's approaching the slant asymptote towards negative infinity. Asymptotically, the graph is wrong, of course. The calculator is wrong. They are not overlapping, but they're so fine, they're so close that the calculator shows us if they are overlapping. They're not. So it comes to a minimum, which we know is at 2,4, and then gets closer and closer to the slant asymptote, and the same way here. Any questions? Perfect. So now we want, I'm sorry, I didn't mean to stop sharing. I wanted to go to the book. We want to choose other problems in which we want to determine the slant asymptote. So here are other situations in which we will determine the slant asymptote. So let me know which one you would like to pick. So please pick, or I will. 1, 1.5, 2, 2.5.
Maybe one just other than 65, because 65 is similar.
Good. So what about 67? Good. In 67, we have y equals 2x to the third minus 5x squared plus 3x divided by x squared minus x minus 2. This would have never worked with synthetic division because the denominator has to be either x plus a number or x minus a number. Perfect. So this is clearly the long division, but I have to do some work first. This is correctly presented in descending order, but this one isn't. Oh, I'm sorry. It's cubed. So did I copy it in the correct order already? No, it was already. Okay, that's fine. So yes, degree 3, degree 2, degree 1. So both of them are in descending order. So that's my first concern. Perfect. So 2x cubed minus 5x squared plus 3x. And we are dividing by x squared minus x minus 2. Remember degree 2 and degree 3 and degree 2? The result, which is the quotient, has to be degree 1. So let's start. X squared times what is 2x cubed? X squared times what is 2x cubed?
2x.
Yes. At the top, we never lie. So 2x times x squared is 2x cubed, but I have to switch the symbol because I subtract. I move on and distribute 2x to negative x. I have to distribute to all three. So 2x times negative x is negative 2x squared, positive 2x squared under the like term. 2x times negative 2, negative 4x. I have to change the sign, and it has to be written under like terms. I know I got rid of this. I know I have negative 3x squared, and I have 7x here. Final question. X squared times what is negative 3x squared? And we do not lie at the top.
Negative 3x.
Negative, careful,
Or negative 3.
negative 3. Good. We distribute negative 3 to all three and write under like terms. Negative 3 times x squared is negative 3x squared. Change or switch. Negative 3 times negative x is positive 3x. Switch. Negative 3 times negative 2 is positive 6. Switch. 4x minus 6. So this function, which was 2x cubed minus 5x squared plus 3x divided by x squared minus x minus 2, can be presented as. Can anyone give us the quotient?
2x minus 3.
Very good. I have to put a symbol plus the remainder that gets boxed in divided by the divisor x squared minus x minus 2. And again, I know I sound like a broken record. Where is this going, this fraction going when x approaches infinity or negative infinity? Where is this going?
Infinity. Or 0, yeah.
Because the degree of the top is smaller than the degree of the denominator. How do I know that it's going to 0? Degree smaller in the denominator than degree in the numerator than the denominator. So if it's degree 1 and degree 2, as long as the degree in the denominator is higher, the answer is always 0. Good. So because this is going to 0, can anyone give us the slant asymptote?
Y equals 2x minus 3.
That's it. Which means that this function follows the slant asymptote with a positive leading coefficient. So it will go to infinity as x approaches infinity, and it will go to negative infinity as x approaches negative infinity. You don't have to determine the limit again. You already have the slant asymptote, and the function has to follow it, either from below or from above. Either from above or from below. Since it's positive, it has to look like this. Positive leading coefficient, positive slope. Good. Are we okay with the slant asymptote now, or do we need other examples? Anyone, please? Are we okay? Are we okay with the slant asymptote? Please say something.
Yes.
Okay. So now I have one more thing to show you before we move on, and I think this is page 9. Hole or hole in a graph. So if I have a function that is, let's say, x divided by x minus 2, does it have a vertical asymptote? Does it have a vertical asymptote?
Wouldn't it be 1?
Not horizontal. I switched on you, sorry.
Oh, sorry.
You are right. Y equals 1 will be the horizontal asymptote, no question about it. But I was asking about the vertical.
Would it be where x is 2?
Exactly. Follow my lead now for the second example. So if we don't look at the numerator, you will normally say x equals -1 and x equals 2 are vertical asymptotes. Would you agree with that?
Yes.
However, if we look at the numerator or we don't, you will still have to say that the domain of this function cannot contain -1 and 2. Guaranteed. This piece cannot be 0 and this piece cannot be 0. That's guaranteed. The domain has to exclude -1 and 2. But now, which we did not have before, look what happens next. After I state the domain, not before. That's why I covered it up. And I said I have to find the domain first before I touch the function. After I wrote the domain, then I can touch the function by simplifying it. So the new function, or the simplified form now, is x over x plus 1, which means the factor that stays, it's still a vertical asymptote. But the factor that disappeared is no longer a vertical asymptote because it disappeared. Is a hole in the graph. Hole? Yes. At x equals 2. What is the y value? 2 over 3. 2 plus 1. I plug in 2. In the simplified form, not here. If I plug 2 here, I'll get 0 over 0. But in the simplified form, if I plug in 2, I get 2 over 3. And that is the hole in the graph. So I want you to understand the difference. So when I graph this function, I'm not going to unless you want me to. When I graph this function, I will graph a vertical asymptote at -1, but at 2, 2/3, I will graph this. Not a vertical asymptote at 2, but a hole, which is 2, 2/3. Why? Because I was able to simplify this factor. If the factor disappears, I cannot have a vertical asymptote there. If the factor stays, I must have a vertical asymptote there. Any questions on this, please? Any questions? Now, you can say, let's graph it, and we'll continue graphing it. Same way, with the table, the first derivative, the second derivative, x and y intercepts if they exist. I already have the limits, because we already, yeah, I don't have it. It's for the other function, but very easy. You let me know. Please make a decision. We want to finish it up, or we want to move on to something else and we understood this concept.
Can we finish it up?
Yes, very good. Let's finish it up. Great job. I'm on page 10. See, I praised myself. No, I was praising you, actually. Good. So f prime of x, f of x, and the second derivative. We know the function does not exist at -1. At 2. So x equals -1 is a vertical asymptote, so I have to find the limits. But for x equals 2 is a hole in the graph, and I have 2/3 on this one, on this side, and 2/3 on that one. Clearly done, because I have the point. Good. So now the function, we do not graph the original function. We simplified it. So we will graph f of x, which is the same, x over x plus 1. Can immediately anybody give us the answer for the limits? At infinity and -infinity.
infinity for infinity.
Careful. So let's take a look. I know it's a lot. It really is. Which category is it? X over x plus 1. Which category is it? X over x plus 1. 1, 2, or 3?
1.
Yes. So then how do I determine the limit? So you told me here, right? You said that y equals 1. What about here?
It's also y equals 1.
Exactly. Y equals 1, horizontal asymptote. Awesome. I have to plug in 0 and I get 0. And now the only thing I'm missing is a left and right. I know they're infinities because it's a vertical asymptote, but I don't know the sign. So with negative 1.1, what will be the sign? With negative 1.1. Negative 1.1, negative 1.1 plus 1. I only need the sign, and I'll put the sign in here.
Positive.
Exactly. With negative 0.9, negative 0.9, negative 0.9 plus 1.
Negative.
Exactly. Done. Finished. Finished. So now I'm moving on to the first derivative. So f prime, the top prime is 1 minus the top times the denominator prime, which is 1. So this is 1 over x plus 1 squared. What do you think about the sign of this function? Because I have to put it in. It's never 0, by the way. But I have to put it in. So what is the sign that I will put in?
Positive.
Always. Thank you very much. Because this is always positive and this is always positive. There's nothing that can change to negative. Okay? Careful now. This is our moment of truth. If these two do not work well together, I'll say stop, 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 stop. From 1 to infinity. Correct? Correct or not?
Yes.
From negative infinity to 0 to 2/3. Correct? See, if I put here by mistake positive infinity, then I'll say, oops, how can from positive infinity to 0 be increasing? Not possible. So from negative infinity to 0 to 2/3, is that correct?
Yes.
From 2/3 to 1, is that correct? Of course. So finally, we'll look at the second derivative. But I will change, at least in my mind, I will change this to this because this is easier to differentiate. I'm not going to differentiate a fraction that has a number at the top. It's a waste of time. Or we could make an error. So bring down negative 2, subtract 1 from the power times the inner function prime, which is 1. So this is negative 2 over x plus 1 to the third. And remember, I will always, at least in my mind, look at this in this way because I don't want to waste my time with a quantity that is always positive. 2 over x plus 1 squared will always be positive. It's a waste of time. So the sign is given by negative with x plus 1. So to the left of negative 1, please plug in negative 10. Negative with negative. What is the sign here? Negative 10?
Positive.
Yes. Let's plug in 0. When I plug in 0, I get negative. When I plug in 10, I still get negative, of course. So therefore, opening up, opening down, opening down. No point of max min because it's always positive, no sign change. No inflection point because it's undefined where the sign changes. Not symmetric. It cannot be symmetric with a vertical asymptote at negative 1 and a hole at 2. Everything is gibberish now. Waste of time to look anywhere. That's all I need. That's all I care about. Nothing else matters at this point.